Alright, so on the left side over here we have our basic rules of exponents or exponent laws. So the idea is if you have the same base and you multiply, you add the exponents. If you have the same base and you divide, you subtract exponents. If you have a exponential and you raise it to a power, right, you multiply the exponents. If you have something raised to the negative power, it's the same thing as 1 over that thing to the power. And a to the 1 is supposed to be equal to a. And then we'll talk about this, why if you take something to 0, you get it equal to 1. But let me answer your first question here. So I don't understand why the negative exponent turns positive when you invert it. Okay, so let me do an example. So let's do like 2 to the negative 3. And I'm guessing what you mean by invert is I do 1 divided by it. And your question is, why is this equal to 2 to the positive 3? Okay. One easy way to see this is to rewrite what 2 to the negative 3 is. So you can say, oh, this is 1 divided by, and 2 to the negative 3 follows this rule here. It's just 1 over 2 cubed, right? So this is like code for 1 over 2 cubed. So it's just 1 divided by 2 cubed. And then we're taught if you divide by a fraction, to simplify it, you multiply by the reciprocal. So this would be equal to 1 times 2 cubed divided by 1. And then you notice, of course, ones you can say cancel, or actually you just drop them off because they're just ones. 1 times anything is anything, and anything divided by 1 is anything. So you get back here 2 cubed. All right, so you have this basically this string of equalities here. You start with 1 over 2 to the negative 3, and we say, oh, okay, it's equal to that. And we know if we divide by a fraction, we multiply by its reciprocal, and we finally get this to equal to 2 cubed. So you can actually write down a rule that if you take 1 divided by anything to the negative power, so minus m, it will be equal to a to the m. And you can run through this argument over here where you see a 2, you write an a, where you see a 3, you write this m, and the whole thing follows from that. And that's one explanation. Another explanation that you can give is that you can say that, again, you want to show why is this true? Why is 1 divided by 2 to the negative 3 equal to 2 cubed? All right, so another way of doing this is to rewrite this thing. All right, so what's this thing equal to? Well, I can rewrite this as 2 to the minus 3 to the minus 1. All right, so 1 over 2 to the minus 3 is actually equal to that. Why? It follows right from this rule. Okay, so if you have something to the negative 1, right, it's just like putting it down in the bottom. So 1 over 2 to the negative cubed. Right? So these are the same thing, really. And then you can actually then use this rule right here, right, which tells you if you have something raised to the n power, then you raise it to the n power, you multiply exponents. So this is equal to 2 times minus 3 times minus 1. And we know if we take a minus 3 times a minus 1, we get a positive 3. Right? Negative times negative is a positive. Right, so that's another way to show why the negative exponent turns positive when you invert it. And again, you can, instead of writing a 2 here, you could write an a, and instead of a 3, you could write an m, and this all will follow. Right. Your next question is a little bit harder to answer in a sense because it's actually asking in a way to sort of prove why this is so. Why is it when you take a and you raise it to 0, you get back 1? So your question was why a number with a 0 exponent automatically turns to 1. So I'll attempt to answer this the simplest way I know how. So the idea is this. Let's take a number. Let's take 3. and raise it to the 0. And we want to show that this has to be equal to, or y, this has to be equal to 1. Right? And so let me just say, if you take 3 raised to the 0 and we multiply it, let's just do by 3 to the 1, what do we get back? Okay, so we can use one of these rules here. We can use this rule here. And it says that basically a to the m times a to the n is equal to a to the m plus n. So you add exponents. So in this case, we would add exponents to get 3 to the 0 plus 1. And so that's equal to 3 to the 1. And so what we have here is that 3 to the 0 times 3 to the 1, which is just 3, is equal to 3 to the 1, which is 3. And we see if we divide both sides by 3 now, right, 3's will cancel. And on the left-hand side, we have 3 to the 0 has to be equal to 1. You can repeat this argument with, instead of using 3's, you can just use a. So you want to show that a to the 0 has to be equal to 1. What you would do is you'd say, okay, well notice if I take a to the 0 times a, right, which is a to the 1, this should be equal to a to the 0 plus 1. Right? You add exponents. And so then you have a to the 0 times a to the 1 is equal to a to the 1. You can divide both sides by a. Right? So you divide both sides by a. And you get a to the 0 equals 1, right? Which forces this to be true. And really what this is sort of a definitional thing. For all these sort of rules to work, right, you need this condition to be satisfied. Otherwise, this wouldn't work. If you multiplied 3 to the 0 times 3 to the 1, and 3 to the 0 wasn't 1, you would not get back 3. And so, in a sense, you know, this has to follow from this up here.